Okay, so I want to give you the perspective of someone who has never opened Xcode before. So let me real quick remember how to do this. I quit Xcode and I bring it back up. So you're on your Mac, you've downloaded Xcode from the App Store, you click the icon and you're presented with this screen, and what do you do? I remember having that anxiety when I started. I've been doing this now for 7.5 years. I started coding with iOS 6 right before iOS 7 came out. So I started with Objective-C and I came on to Swift. And I remember seeing this and just being terrified at what this meant. I worked on a team and I saw the code that they were writing and I was terrified because I could not read it. I had no idea what I was doing. And meetups like this didn't exist back then, so I didn't know who to go to ask questions apart from people that I was working with. Some of those questions were kind of embarrassing. So there's no such thing as an embarrassing question here. Anything that I'm doing, anything that I talk about, anything at all, please ask it in chat. I've got you on my second monitor so I can watch. And if you're coding along, I highly encourage it. If you're not, I will put all this code up on GitHub later. And there will be a link to the GitHub in the YouTube video. So if you didn't catch it, I'll do it again because I kind of talked and clicked. I clicked on Create New Xcode Project. There used to be other options there, but they simplified it, which is great. And we're going to... where is it? Let me try again. No. Okay, let's go in here. File new playground. We're going to start with a Swift playground. Now this is different than the Swift playground app that you would get on an iPad, but conceptually they're sort of similar. Swift Playgrounds, the app, is sort of like a guided teaching tool where you can execute code without really building a larger application. A Swift Playground in Xcode is similar, where you get to write and test little chunks and snippets of code before committing it into a larger project. I use these a lot if I'm sort of trying to figure out an algorithm or an idea, or I want to play with a topic I'm not so familiar with. I'll open up a quick playground because then I don't have to build an entire app. I don't have to navigate through it to get to a specific screen. I can just write a little snippet of code here, test and play. And I actually save these. I have somewhere in my mess of things that I need to clean up. I keep all of them. They're somewhere in here. I save all of my playgrounds. I put them up in the cloud on GitHub so that I have access to them everywhere, so I can reference old things. And I use them like snippets that I wrote years ago. I reference to this day. None of them are specific to any job, so any of my past employers that are watching, don't worry. So I'm just going to make a quick folder here so that I have somewhere to, still have last year's folder. Let's call that 2021 then. Happy 2021, everyone. And I'll call this Basics. So we're creating a playground called Basics. We're putting it into a folder that's on my desktop or wherever you would like to if you're coding along at home. And we're hitting Create, and we are given this screen here. So already Swift Playground comes with a couple of things written on it. The first, we are importing UIKit. You can kind of ignore that for the moment. We're not going to be using UIKit for this portion of, or really any portion of tonight. But it gives you access to the stuff that is UI, the stuff that you would see on a screen when you're holding a phone with an app on it and so forth. But more importantly is the next line, the very first line of code. This is a variable declaration. So I know that because I see the word var in the front. Var stands for variable. The next three characters are the name of the variable. So in our case, it's str, which is short for string. We have an equal sign, and then we have hello playground surrounded by two quotation marks. Quotation marks in Swift and most programming languages, if not all, indicates a string. And so we are saying the word or the sentence hello playground is being set to the variable str. So if I come here and I say print str, and I hit this little blue arrow over here, pull up my little console. If you didn't see, I clicked on this icon down here. That brought up my console down here, and when this finishes running, usually doesn't take this long, but sometimes my computer is a little bit slower with streaming, we should see printed down below hello playground. There it goes. We also have a little debug pane here on the right side of the playground window. So you can see we also, here it's saying I have set the value, hello playground, and then here you can see hello playground again with a little /n at the end. That is just a new line character. So the print function, which we'll get into what functions are, adds in that little new line for us so that the next print can be on its own line. Okay, so let's say I wanted something that is unchangeable. So a variable is just that. It has a variable value. So let's change hello playground to hello stream. And if this catches up with me, over on the right now we see hello stream. We don't see it printed below because I got rid of our print statement. So I have taken the value of str, which used to be hello playground, and I've changed it to hello stream. And to further drive that home, let's just print it again. We'll print it there, and we'll print it here. So it used to be hello playground, and now it is hello stream. Again, if you have any questions along the ways, please feel free to ask them. Two notes, I really appreciate that you like our Discord. That means a lot. It's really new. Okay, so sometimes in programming, there are values that you want to never change. We generally call those constants. In some languages, you might see const in front of a line. That's a constant. In Swift, we changed our keyword var into let. And so now, if I run this, you can see we get a big bad error. Cannot assign value str is a let constant. And so I can no longer change the value of str to hello stream. I'm gonna say like greeting. Ooh. All right, do a little bit of code reorganization right quick. Okay, so I've got hello stream here twice. Why don't we just make this greeting to further drive home that str is a variable. So it can change value, but greeting cannot. That is a very important concept to understand when programming. Things you don't want to change might be text for a label. It might be values that help draw your UI. It might be just static text that goes onto the screen. Anything that should never change, you generally want to write it as a let. I think there are some performance benefits from doing a constant over a variable, but obviously you need variables because you need things to change because the world changes. So a string is one data type, and we can be more specific with it. Swift is smart enough to say, hey, you've got 2 quotes on the right side of an equal sign. That means this is probably a string. If you're more explicit with it, some people think it makes the code a little bit more readable. It does make the code a little bit faster, but that really doesn't matter until you start having hundreds of thousands of lines of code. So pick whichever one looks prettier to you, makes more sense to you as far as adding explicit types. I know a lot of teams choose not to be explicit with the types. Did you select app? No, I did file, new, playground to get to this. I will be selecting app in a little bit, but right now we're just playing in the playground. Joe, not that you should rely on it, but doesn't Xcode point out any vars it finds that should never change and let them be lets? Yes. So the Swift compiler is smart enough to say, hey, here are a couple optimizations you can do with your code. It's generally smart to pay attention when Xcode tells you a thing. And we'll probably see that a little bit later as we dive into building a small calculator app, especially because I don't know a whole lot of Swift UI, and we're probably going to have some things like that. Okay, so those are strings. We also have other values, or other primitives as they call it, where we can say, for instance, have a variable that I'm going to call sum, and I'm going to have it equal to 0. Same with string. Swift and Xcode are smart enough to figure out that the type of sum is an integer, which we declare as a capital int. God, I always forget the names of things in math. Divisor. Divisor? Divisor. Yeah. Well, so we have floating point numbers in this as well. If you option click on something, you can also see basic information about it. So divisor is a double, and Swift is smart enough to say, okay, you've got a decimal here, let's make that a double. There is also something called float, which is very much like a double, but slightly different in that, you know, it has a floating point or the period to say that you have a decimal value. It is used for other things. Divisor. Thank you so much, 2 Notes. There was this moment of like sheer panic when the word just escaped my head, and I was happy to even remember how to say it, let alone how to spell it. Okay. So now that we have something called sum, let's write our first function. And what a function is an isolated piece of code that you can call elsewhere. So for instance, print is a function. They wrote it once, it's down deep in the language, and when we need it, we can call it and we can do something with it. In this case, we're putting text into the console. For our sake, I'm going to make a function, which we start by declaring a function with the word func. And I'm going to say add. I'm going to put an underscore here, and I'll explain what that is in a minute. And I'm going to say value : integer. Now up here, we did not need to specify the type that our variables are. In our case, we do in a function because the function needs to know what it's getting back in. To finish out our function, we make an opening curly brace, hit enter, and Xcode puts in the closing curly brace for us. So here we have the body of a function. Down here, I can now call it, and I give it 1, but because there's nothing in our function, nothing's going to happen. But watch, as we start adding code, some things are going to change there. I'm gonna go take this toy away from my dog real quick. I'll be right back. Okay, no more crinkles from my dog. Okay, so we have our variable sum sitting up here, and I want to add a value to it. So we can do something as simple as sum equals sum plus value. And so if I run this code, we can see, let's do a print after. We'll print sum. You can see that we've got the value 1 down here. And so let's add a couple more add function calls. And we'll print sum once more. So now every time that we call into this add function, so every time we type add open parenthesis some number closing parenthesis, we're calling into this function, and it is taking the value of sum, adding the value that is passed in, and then assigning it back to sum, our variable that we declared here on line 11. And you can see through sheer luck, because I was not paying attention to the numbers I was writing in, we have somehow made the number 30 at the very end by adding 1 plus 10 plus 6 plus 13. There are shorthand versions of writing this. So if you don't want to write equals sum plus value, we can do sum plus equals, plus equals value. And if I run this again, you'll see we'll still get 30 down there. This is just super convenient shorthand, which is nice if you have longer variable names. And so taking a half step back, you can see I have with my function add and then a number. Let me write another function. If I call into this divide function, you'll see its function signature is a little bit different. This function has the word by in it, and that's because we name our function parameters. And Swift gives us this little nicety where if we have two values or two variable names before a colon, it takes the first one and it lets us make a little bit prettier functions. So here I can return value divided by divisor. Wait, nope, did that wrong. Sum divided by value. Value being the thing that we're going to divide. If I changed this so that I didn't have value here, I would get a different error than what I'm getting here. So it can't find value in scope. I would have to change this to by. So whatever we put into the parenthesis, we're able to access inside the curly braces. Another way of saying that is we're defining what someone outside of our code can tell the inside of our code what to do, or how like values of things to work with. You don't have to have two names for your variables. I like to make my code a little bit more readable. I wouldn't say readable, readable like a sentence. And so like this, you're getting like divide by divisor, divisor being 2.5 up here. Now Xcode is super kind in that it has told me that I have an error. So anytime you have, I don't want to say anytime, a lot of the times you have a red line across your code like this, you get a little window that pops up like that. It's got a little stop sign. If you have a stop sign as opposed to another red box, you can click into the stop sign and it will tell you what the error is and any number of potential solutions it might have. And so in our case, the language does not let you divide an integer by a double. And so in order to do that, we have to do something called casting, where we are telling Swift and Xcode that the value of sum needs to be turned into a double so that I can divide it by the word value. So if I run my code again, 30 divided by 2.5 is apparently 12. And for giggles, let's just divide that once more. Oh, it'd be 12 again. That's a very, very good thing that I just noticed. So here, here we are assigning the value back to sum. Here we are just returning the value. So I am not changing what sum is. I'm just dividing sum by the value. So let's instead divide it by 3.5. And that ends up being 8.5 oh geez, that's so many things. How do you just print the value of it? I guess you can't. So yeah, basic math, basic Swift. Let's dive in and start using some of this knowledge. So in all of the years that we have ever done this meetup, and all of the years we've ever done Beginner's Night, we have used UIKit to do this demo. Tonight we're going to use SwiftUI. It is Apple's new declarative way of creating UI, which is to say that you write code as opposed to using a storyboard or a zib where you can drag and drop UI elements, or using UIKit, which if you remember from our playground, we had import UIKit at the top. We're going to use SwiftUI instead. I am a complete novice at SwiftUI, so forgive me as I stumble through that. So we're back here on the first screen. If you forgot how we got here, we clicked on Xcode's icon and we hit create new Xcode project. And now that we've done our playground, you can see it's up here on the right as recent projects. So we click on that create new project. We're going to create an iOS app. I'll hit next. We're going to make a calculator because I love making calculators in this. We're going to change our interface. Oh, I'm jumping way down. If you have a developer account, you might have a value here. You might not. It might be none. You'll be asked to make a organization identifier, which gets translated into a bundle identifier. The industry standard is to have this be the inverse of your website. If you don't have a website, you can kind of put whatever you want in there. I say that with like a huge asterisk around it, where eventually if you do publish your app to your app store, this value is shared with Apple all over the place. So it's kind of better to follow the standards, or at least have something that you'd want your grandma to see. Next interface, we're going to change from Storyboard to SwiftUI, and we're going to hope for the best with that. We're going to change lifecycle to SwiftUI app because we're going to be building a SwiftUI app. Our language is Swift. We're not changing that. We are not going to use core data in this, but if you're curious, core data is like a database technology that lets you store information on the device so that you can sort of pull values out of it quicker for your app. And we're not going to include tests, but if you go to our YouTube channel 2 months ago, we did a session on tests, and that will be published tomorrow morning at, I believe, 7 a.m. I'm going to hit next. I'm going to put it in that same directory as my basics playground. And I had a box checked to create a Git, and I'm actually going to go fix that because I don't want the Git to be where the default is. Do not do what I'm doing. I'm doing this just so it's easier for me to upload the code later. Okay. And I'm just going to do a quick little bit of other things before I forget. What I'm doing in the terminal right now is I'm creating a new Git repository for our project. I'm not going to cover Git too much tonight, but it is a nice way to store your code so that if you have multiple computers or you want to share it with other people, it's a place to sort of dump your code and be able to share it or look back to it later. So what I've just done is I've added a quick git ignore file, which removes unnecessary gross code. And I put it at the base of our project so that when I upload this to GitHub later, you get everything, not just the app we're building. That is going to be the only stuff I do in terminal. Hopefully, I'm going to try and use Xcode's Git editor from here on out. Try to keep me honest with that. I'm not super great with it because I haven't used it for 5 years. I usually do other things with Git. Okay, so we get what we're looking at when we start a new project. It will create a file named app, that is the name of your app, so calculator app. You have a content view, which you can see our content view is created and is put inside of something called a window group that sits inside of something called a body, which is a scene that sits inside something called calculator app, that is an app. You might recognize some of the syntax here from our playground. It's a little bit different though. Instead of func, we have struct. A struct or a structure is just another grouping of code. A structure can be variables and constants as well as functions and other code. It is something called an object, which means we can take it, bundle it, and pass it around as one whole thing. When you want to get really nitty-gritty with it, we have structs and we also have class. And a class is very similar to a struct, and it can have variables and it can have functions. The difference is how they are stored in memory. A struct is a value type, so when you pass it from one place to another, you're passing the value of it, you're not passing the thing itself. A class is a reference type, which means it's saved down into the memory, and so when you pass it around, you're passing around the same thing everywhere. Another way to think about that is anytime you pass a struct around, you're making a copy of it. Anytime you're passing around a class, you're passing the thing. I don't think classes are majorly going to be used tonight, but it's an important thing to know because sometimes you need that single reference, that single object. The content view is the UI. And so when you're building a Swift UI app, we get this nice little automatic preview window. So if I hit resume here, you will eventually see our content view come up. And real quick, while that's going, we'll talk about the anatomy. Every content view is a view in Swift UI. Every content view is a struct, I believe. Don't quote me on that necessarily. Every view has a body, and inside of the body, which is this is a computed variable. Excuse me. What a computed variable is anytime you access it in code, iOS goes and reruns whatever is between its curly braces. So every time this content view's body is referenced, it goes and creates something called text, and it applies some padding to it. And so when it comes up visually, yes, struct classes cannot be SwiftUI views. Thank you, Zev. So once this has come up, we now see a nice little preview of our hello world. I can change this to hello stream. And our preview should resume itself. It sometimes gets a little finicky. But the idea is that it stays up and running so that I can remove the exclamation mark, and you can see over here on the right, the exclamation mark is gone. Of course, though. No worries, man. Thanks for watching. This little thing, this dot padding, is called a modifier. So we have all these little dot things. This is where that declarative syntax comes from with SwiftUI, where after we've declared a UI element, we can add modifiers to it to change it. So I can add dot color, foreground color, and it's suggesting blue. Let's call it blue. And you can see now my text has gone blue. I can change that to not its suggested value. Let's say cyan, which is just another pretty blue. It doesn't like cyan. It is not a color. So if you don't know what the colors are, you can do a capital C color, hit dot, and it will tell you all of the ones that were given for free. So that's going to be yellow, white, secondary red, purple, primary pink, orange, blah, 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 so on and so forth. Or we can define our own color by using, functions. Oh, geez. It just adds in a whole bunch of things for us. Okay. So the very first thing that it needs is a color space. I don't know what that is, so let's hit period and see what comes up. Let's say sRGB. And next we can provide a red, green, blue, and opacity. So if you've ever done something in like a Dreamweaver or Photoshop or even like MS Paint, you might be familiar with RGB. Colors in computing are created by combining how much red there is, how much green there is, how much blue there is. And that is generally a value from 0 to 255 for reasons that I don't know. Yes, 2 notes. You can do UI color as a color, correct. So if I make this 255,001, we're going to see our hello stream becomes red. If I make this I think that works. Oh yeah, 0 to 255 is 256 is 8-bit value. Thank you. Let's bring in some blue. So I made a fairly pleasant little pink here by combining all these colors. Yeah, so that's adding that. Padding is kind of like a special one where it just like does fun things for you. You can add in extra values if you want to add insets or lengths and edges. Let's do this. We'll add in some padding on the bottom. We'll make it 100, 1,000, 100. I don't know what that's about. All right, we're gonna ignore that. Like I said, I'm very new to SwiftUI. I don't know everything I'm doing. Ignore everything I just did. Yeah. Okay. So I want to make a calculator. This app is really good, and so I'm going to use it kind of as a means to, or like as an inspiration. And so at the top, we're going to have a label. that we're going to store our sum in. We're going to have some numbers and some operators. So the very first thing we're going to do is I'm just going to pop a variable outside of here. I'm going to find a better place for it in a minute, but I want to make sure I can do what I am thinking I can do. We'll resume our preview. Sweet. So let's get rid of our padding. And I'm going to give this a background color of sometimes you'll notice Xcode no longer helps you complete things. That happens when it gets a little bit confused about what's going on. Is it just color? Is it accent color? Chat. What is background color in SwiftUI? Takes a view, no autocomplete, not a color. All right. Well, if you've noticed, I have a little counter at the bottom of the screen for the number of times that I've needed to Google something. We're going to use that a lot tonight. Color is a view, so I should just be able to do color dot gray. There we go. Yeah, I knew this. I'm just panicking. Okay, so we're gonna have a little background color to it. Let's make it a little bit bigger. Font weight, not font weight. We'll Google it again. Go with headline, see if that's large enough. There are different values for native fonts. So you can see there's body, callout, caption, so on and so forth. You can declare custom fonts, but using these native ones is usually the suggested way of going about it, because you get some accessibility features for free in there. It's like if your users are a little bit hard of seeing, they might want to adjust the font size, and using these baked in system ones will do that for you. That does mean that you have to have San Francisco is your font. People generally don't find that too offensive. Padding. Padding is not what I thought it was. So by typing the period, I am looking for all the different modifiers that I can do to my text. And I am looking for one of the placement things. Believe it or not, I did go through the SwiftUI tutorial that Apple puts out. It's really good. I just did it over the summer and then I never touched it again. So a lot of the things that I'm trying to do, I remember that I can do them, I just can't remember how I can do them. And so we'll go back to our good friend Google. Where is the tutorial? Great question. There you go. Them saying that it takes 4 hours and 25 minutes is pretty estimated, but it does a good job of walking you through. It goes through the basics, or the essentials as they call it. You do some animations, you make some pretty cool things. It is not as extensive as I wish that it was. But it covered enough that I could start to feel like I was doing things. You know what? Good call. So if you've done UI kit programming with Swift, you might be familiar with a stack view. We have that in SwiftUI as well. They simplify it, and in fact, they even let you take something. Oh, I'm remembering. And if you command click on it, you can embed it into an H stack, which is your horizontal stack view. So your elements will be lined out left to right. You can put it into a V stack, which is a vertical stack view. It lays them out top to bottom. Or you can put them into a Z stack, which lays them out closer and closer to the user. In our case, we want our sum to be at the very top, so we'll put this in a V stack, and hopefully we see this jump to the very top. And if we don't, we can put some padding down here. And now it's gone. And now it is gone. Oh, spacer. Spacer is what I want. Also, I think I owe you a Google button. There we go. So a spacer is a neat little view inside of SwiftUI that fills up all of the space to the edge of whatever axis it's on. Let's see if I can give this a foreground color so you can kind of see where that's going. Nope. Maybe background color. See if this catches up with us. It is not. All right, I can't give it a background. That's interesting. But yeah, so that's what's going on there. Is it just fills up all the space for us. So next, we're gonna start super simple. I want to get a button on the screen. And then after our button, we'll have another spacer so that it's like super up high. Now we have a couple of different function or method signatures here. In our case, we're going to start with title and action. And our title is going to be 1. And our action is going to be sum equals 1. So our button's kind of small. So let's make it a little bit bigger. So I gave it a nice little padding of 10. And so if I put on our live preview, I never really covered that. So when you launch Xcode, you'll have your preview like this. It's just kind of a flat little screen. As you add things on the left, they'll show up on the right. But if you want to interact with what you're building, you can hit this little play button here, as opposed to the play button up there. And now this becomes a little bit more interactable. So I can tap on my button and nothing's happening. Well, why is nothing happening? So let's click on the number 21 here. We get this nice little blue thing pops up. And I click into that, it doesn't work. Okay. So what this little blue thing is called it's a breakpoint. And so when you're running code, it's constantly executing line by line by line, and a breakpoint will stop that execution so that you can look at things. If I click on it again, it goes little opaque. And so I want to click this a few times. I'll bring my breakpoint back in, and I'll click it once more. You'll see now it stops. And I want to see what the value of sum is. So it was 0 and now it's 1. So my button's working. But I would expect that by changing the value of sum, I would update my little label here. And that doesn't seem to be the case. This is because Swift UI draws the screen once. You can redraw certain aspects of it, but you need to let Swift UI know that it needs to redraw itself. And we do that by putting in, I forget the name of it, and I think that they just changed the name of it. But we call this variable now a state variable. It's a property wrapper, but I feel like they changed the name of it. So by declaring that this is a state variable, we're telling SwiftUI that we expect this thing to change. And so I'll rerun my app, and if I tap my button, I see 1 go up there, which means great. We've hooked that up now. Is this still property wrapper? I thought they changed it. I might be thinking of something different. I thought it was another one of those. Is it function builder they changed the name of? Yeah, result builders. Okay, so we've got our pretty pink output. We've got our little button. Let's give it a slight background color as well. What is accent color? We'll resume our preview. That'll happen a lot while you're developing in SwiftUI, where your preview will just kind of stop. Don't want it to be accent color. We'll just make it gray. I don't like gray. That's the one I want. Doesn't show up super great on my screen, but it looks like it shows up a little bit better on stream maybe. Let's give it a border just to be safe. Yeah, we'll go with the black color for now. That's good. So now we've got our nice little one button. I definitely have opinions about the way that SwiftUI chooses to indent things. I would expect these things to be pushed over, but they're not. I find that a little upsetting, but you know, to each their own. Okay, so we have a button that now makes our sum 1. That's somewhat useful. Let's add in another button. And we'll again use title and action. This one will have a plus. We'll do something super simple for now. We'll do sum plus equals sum. And we'll give our plus button the same button treatment. Okay. We'll give this a run. And we'll do sum, so we'll set it to 1, and we'll hit plus, that should make it 2. We'll keep hitting plus, and it's just doubling itself, which is not really how addition works, but proves the point that now we can start interacting with our calculator. And anytime I hit 1, it resets it back to 1. That's interesting. It's a very interesting calculator. So this is no longer really a sum. This has now become sort of a display value. So let's right click on this and we'll say refactor, rename, display value. Now I don't like, ooh, what happened here? There's a command for this. Isn't it like command comma? Nope. How do I bring back my preview window, chat? Canvas? Canvas. Now I don't like my buttons being vertical like that. It's kind of weird on a calculator. So I can highlight all these things again, and I can say embedded in H stack. Highlighting doesn't work, but I can just bring my button up into it. Command Option Return. That's super straightforward. Oh, that's so weird. Oh, I see what's happening. It's just wrapping. Close all those things. So make the code bigger, make our preview smaller. So now that this is put into a H stack, you can see our buttons will go from, instead of being on top of each other, to beside each other, which is super cool. We will still need a value sum. So let's create it. We'll change it around like that. Cannot change it around like that. And we're going to add in another button outside of our H stack. I'm just going to copy and paste it so we get the same visual treatment. We'll make that our equal sign and display value equals sum, which means we can go back to sum plus equal. Let's make it display value. Let's see what happens there. I guess I also have to make this a state variable. And let's see what fun stuff I've just built. So because I'm saying this on display value, we're not getting a whole lot. But I can hit my plus a whole bunch, and I'll hit equal, and then we'll see the value come in. Okay. Okay, so we're kind of getting our calculator going. So I can hit 1, we'll display the 1. I hit the plus, it adds it to our sum, and then we hit equals. So if I hit equals a whole bunch, that stays the same. If I hit plus a whole bunch, this grows a whole lot. I hit 1, it only goes up by 1. Interesting. I'm kind of okay with that. This is going to be a quirky calculator. It's not going to be a perfect calculator. Chat, again, any questions you have as I'm doing this. I'm totally just fumbling through it, but I'll do my best to answer you. Shouldn't we clear the bar if we hit plus? If you'd like us to. I can do that if you'd like. Well, that's curious. So let's try making it an integer that's an optional. And we'll set this to nil and see what happens. Oh, geez. Oh, Zev, you're in the Zoom now. There he is. And bring right cam back in. Everyone, it's Zev. How you doing?
Good. I've been following along.
Thank you for that. And thank you for the little tips and pieces of help. So if I want to clear display value as I hit plus, I need to change it to a string instead of an integer, which means my logic kind of gets weird.
Why display value? Why do you have to make it a string?
Because to clear out its value, to not show anything.
Be empty,
yeah,
but not be optional.
Yeah, I'm not gonna do it.
You can have it be optional and then nil coalesce it with the empty.
Nah, I'm not gonna do it.
String.
I'm just not gonna do it.
Yeah.
Okay. So I hate how much spacing we have around. I kind of want to bring this up. Can I do that? Yeah, I can.
You also have an extra spacer inside your H stack that you maybe wanted to be outside your H stack at the bottom.
I believe that I do. No, that's in my B stack.
Oh.
Yeah. I have the equal sign outside of the H stack.
Oh, yeah.
But this kind of highlights a point that I wanted to make a little bit later in the night, but we've already got enough code that I'd like to highlight it now. If you do everything in the body of your main little view, it will get very unreadable very quick. So we've put, 3 things, really 4, but apparently the 4th thing has disappeared. We put 4 things on the screen, and already we have 34 lines of code that represent it, and this isn't even a third of a calculator. And so you can make other views. And I perhaps want to abstract this out in a way that I am currently thinking about. So I want to be able to make, let's just work through it together. I want to be able to make a view
Do you want to make that a Swift UI view?
I do want to make it a Swift UI
view. With a preview. And...
Does it?
Yeah.
So
lower left.
Gotcha, thank you. Man, I love it when you're here talking to my ear. So I want to make a button view because all of our buttons are kind of the same thing where I've got this background color, this padding. So I'm going to make a button view. And inside of the body, I'm just going to copy paste one of our buttons in. And we'll get this going. Get rid of the body of our action, just so we can get that view back. There we go. Okay. So to create a button view, we're going to need our title because we don't want to always have it be 1. So let's make a variable. It doesn't need to be state.
Doesn't need to be var.
Doesn't need to be var either. I thought so.
It's a little mind-bendy to think about, but a Swift UI is going to be redrawing your whole view anyway. It doesn't need to be internally mutable because it's just going to be replaced with a new one of it.
So I will create an initializer. And I will say that it requires a title. Yeah,
you don't need to.
No?
Nope. It's created for you. You just need to use it in your preview.
Sweet. Sweet. Swift, you're amazing. And just to prove, we'll make this 2. So that when I switch from using 1 here to title, we should see 2 show up in our resumed preview. Sweet. And I'm just looking at this real quick to get the syntax of what action is. That I don't need an action
comma on line 26 after the 2.
Yes. I'll just resume that to make sure it still works. Sweet. So now all of my buttons with all of this extra code I can change to be a button view. And I can get rid of all of the modifiers that we added to it. So we just deleted a whole bunch of code. And we'll make this another button view. And I'll get rid of all these modifiers. And so Zev, I've not built a whole bunch of SwiftUI views. I don't know if you have, but I feel like this would be a pretty common thing where you start to build something and you see a lot of code gets generated and you decide to abstract it out.
Yep. Yeah, they even have a thing that kind of sort of works where, like, let's say hypothetically you wanted to extract out the text on line 17 and all the modifiers after it. If you command click on that text, we won't actually do it, but I'll just show you what it would look like. If you command click on the text on line 17, there's boy, they made this thing longer. And now it's harder to find things. There's extraction method and variable. It's extract subview. Yeah, so if you did that, it would make you a new SwiftUI view. Yeah, in the same file.
Nice, but gross.
And then, yeah, probably want to undo it, but like
yeah.
that gives you a starting point at least.
I've also been seeing in the console that it does not like my 40 divided by 255, so I'll just do that. Okay, so now
it's the red that's complaining. The 40 over 255 is fine.
Oh.
The red is a 0 to 1,
yeah.
Not 0 to 255.
I like that I figured out a color. I wonder if this will still be that lovely pink. Nope, it's a red.
I think it's because everything was clipping above 1 and it was just being clipped at 1.
So yeah, we should see that this still works. It does not. Interesting.
Do you want to debug it, or do you want me to tell you what you did wrong?
Please tell me what I did wrong.
You didn't call the action in the button view.
Yep.
Oh, nice.
Now, curious, that somehow fixes it. So if you have a trailing closure, it jacks up the modifiers.
Yep.
Man. Okay, so now I can run this, and we should see everything works amazingly. There we go. Sweet. So our weird jacked up calculator is calculating again. Let's put a little spacer at the top. I don't like that it's right up on there. Now I thought there was a way that you could give a fixed size to the spacer. Fixed size.
Okay. Yeah, two
With
notes
frame.
mentioned using frame, right? I think there's something. I think fixed size is specific to. Oh, that's whether it's fixed size. Yeah, you would want frame. And then you can give frame an optional width and an optional height, or all those mins and maxes and things, which still largely mystify me.
Yeah.
I think you can get rid of the fixed size. I don't think you need that. Maybe I'm wrong.
Yeah, I don't think you need it.
Oh, can I say a quick thing about previews?
Please do.
So you've got this little play button checked on right now, which means that your preview is actually interactive. You can click around in here and it will run. And then if you unclick this, it won't be live anymore, but your previews will update faster.
Yeah.
And you can like click on the buttons and actually get interactivity in the editor with those.
Indeed. Zev.
Yes.
Can I ask you to take control for a hot minute while I run my dog out?
Sure. What's the next thing you were planning on doing?
I was going to either add in a to button or a divide button.
Cool. All right. I'll give it a try.
Sweet.
Do I have control? Wait.
You do now.
Yeah. Okay. Cool.
Be right back.
Alrighty. So divide button I'd have to think about a little bit, but to button is fairly easy. So I'll go ahead and do that first. We can just change this to 2 and this to 2. And I'll hit the play button here to give that a try. So I also haven't, just because I joined a bit late, I haven't fully followed, because like this is a bit of a weird calculator. What are we actually doing? So we have a display value, which is used here. And then we have a sum. Oh, when we hit equals, it updates it. Okay. Got it, I think. So let me test my understanding. So if we start with 1 and then say equals, okay, that doesn't do anything because we haven't done any operators. So I can put in a number like 1 and say we're going to add that, and then 2 and then add that. Does that mean we're going to get 3? Cool. Okay, so this is like sort of some sort of Polish notation deal. I'm not exactly sure. Okay. That means we should be able to, we can take the display value and make it so we can make it like a bigger number, like not just a single, digit, but a full string of numbers like on a regular calculator. So I'm going to take a hard left turn and do that instead of what Matt said. So for this, I think the easiest way to do this, well, here's a fun idea. So what happens when you push a button on a calculator? So you've got like, let's say you've got a 1 on the screen, and then you press 2. What you would get is you would get 12, right? Because it's adding digits from the right. What you're actually doing there is you're shifting that 1 over, and then you're adding the 2. So shifting a number in base 10 is just multiplying by 10. So what I think I want to do is times 10, and then add new digit. This isn't necessarily the smartest way to make a calculator in terms of like there's some computer sciencey math stuff where the numbers may not be very happy being manipulated like that, but let's give it a try for this example because it'll save me having to do a bunch of conversion between storing the number as a string and then back to a number, and that stuff gets annoying. So I'm going to make a function because I want to be able to update my display value in a bunch of different places. So I'm going to say new function, let's add digit. And I've already said digit in the name of the function, so I'm going to use an underscore to say I don't need to say it again inside the parentheses. That'll be a digit, and it will be an int. And this function is going to display value times 10. So that will shift everything. It basically adds a 0, right? In base 10, multiplying by 10 just adds a 0 at the end. And then display value adds the new digit. And I'm going to just write, if there are things that your code assumes should be true, you should make that clear in your code. In this case, I'm assuming digit will always be a single, a number 0 through 9. But of course, an int could be any number. So there's a bunch of different ways to solve this, and this isn't necessarily even the best one, but I'm just going to say precondition digit is less than 10. And then if we accidentally misuse this code later, this will crash the app and just say, hey, wait a second, you weren't supposed to do that. Just in case somebody comes along later and doesn't really understand the intent of this code, the precondition helps cement that intent. So I'm going to do that. So now I'm going to call this inside these button actions. So I'm going to say add digit 1 here, add digit 2 here. Okay. Resume our preview. Yeah, it does like to. I think anytime the structure changes, the preview pauses, and it has very loose definition or a very, very permissive definition of what constitutes changing the structure. So let's see. I should be able to say 1, 2, 1, 2, and through. And I can add that and then add 2, 2, 2. Oh, it didn't clear it though. So when I plus, do we want to clear it out? I mean, this now gets into like how does the calculator work? Yeah, I think we want to clear out the display value back to 0, as though, you've taken this number and you've stuck it off into your calculator's memory. So now the screen has gone back to 0.
Yeah, that makes sense.
That's what we want. Oh, hey, you're back.
Hey.
So we added a 2 button, and then we veered hard left and made it so that you can make the digits go long.
Yeah, I dig it.
And we did that by shifting the digits by multiplying by 10 and then adding the new digit in a function.
Nice.
So just tacks them onto the end without having to deal with a string, which would have been annoying.
So you did just highlight, whether or not you know it, a bug that is in the app.
Cool.
So you added 12 to 21,122, but it didn't display it because you never hit the plus again.
Mm-hmm.
And then our equal sign still does some weird things.
Looks like it doubled up the whole thing, yeah.
Yeah. So I'll put it to the chat. Do you want us to fix this bug, or do you want us to add more functionality?
I'd love to make a full keypad because I think it's a great example of the kinds of things that make programming really fun, like write a tiny bit of code and have it do this big thing.
Yeah, I'm into it. Joe Cab wants us to fix the bug, though.
Fix the
bug.
Can you demonstrate the bug with smaller numbers so it's easier to see what's happening?
Yeah. Stop the preview, restart it.
Should add a clear button.
Yeah. We can add that in real quick. Let's add that in. Before we demonstrate the button, let's add in a clear button real quick. So I'm gonna embed this into a horizontal stack, and next to it we'll put in a button view. Okay, so I put in my 1, I put in that, then I hit equal. The equal button sign, the equal button isn't updating the display value. You have to hit plus to do it.
That's weird.
The equal is just setting the sum to the display value. But the plus is what's doing the actual operation.
Is that the bug?
Yeah.
Oh, I set display value back to 0 because I figured when you're done entering the number and you hit plus, you're adding it and resetting display value back to 0.
Yeah, that's fine.
To enter the next number. Okay. So you're what are you saying? What are you implying?
That somehow the plus is the one that's actually doing. Wait, what? What? Maybe the bug's not what I thought it was. Plus. Still doing some weird doubling thing. Yeah, so I hit 1 plus 1 equals. It's not 2.
Because this is a different kind of calculator. You hit plus when you want to push something in. So otherwise you're just typing. So you hit 1 and then plus and that adds it in. And then you hit 1 and hit plus again and that adds it in. And then equals displays the running tally, which is not necessarily how you would want it to work, but that's how it works right now.
Yeah. So that's the bug.
So do we want to change it so it works like a regular calculator?
We can. In years past that I've done that, it gets pretty heady. But I do like the idea of maybe making a loop so we can display some more cool code things.
Cool.
To get
want me to do that?
Yeah, why don't you?
Cool. So I'm going to move the plus outside the various stacks. I'm going to make that actually part of the like the operators stack. We kind of have a nice grouping down here now. And then let's think about what we want to do. So we want like a 3x3 grid and then maybe a 0 separately. So I don't think SwiftUI has a great way of just saying, take this row of 0 through 9 and wrap them to whatever available width. Maybe in iOS 14, maybe one of the lazy grid things does that, but we know we want a 3x3 grid, so we're going to do this more an old-fashioned way, which is that we're going to loop through the rows and then loop through the columns, or loop through the columns and loop through probably the rows and then the columns. And I'll be feeling this out a little bit as I do it, so it's going to be a little all over the place until I figure out exactly like it's one of those little fiddly math things where you got to get the offsets just right. So let's see. I'm gonna make some constants. Number of columns is 3, and do I want to do so just to make it really simple, I'm going to say rows equals 3. Some of these could be dynamic, but we know it's a 3x3 grid, so it's not like we're trying to make an arbitrary system for displaying digits. So I'm going to use a construct in SwiftUI called a for each, and for each will run the same bit of code each time while going through a list of things. And I'm going to use it. Normally you would give it like, if you were making a shopping cart, you would give it a list of products, and for each product, it would put the product on the screen. But instead of taking some external data, I'm just going to give it a little range. So 0 up to the number of rows. And this dot dot less than is a Swift operator that gives us a range. It's just a nice little data type that expresses a range. And then for each of those, this will be row in, and we can get into the syntax here, but I want to get it. Basically, I'm saying for each one of these rows, do something, and when you're doing it, tell me which row you're on. That's what this one here is. So on that row, so that row is going to be an integer. Oh, it doesn't tell me. Usually it would tell me the type down here. Cute. So I'm going to say, first I'm just going to say text. It's nice to sort of build these up one at a time so you can kind of see what you're doing as you're doing it.
And I didn't
Option Command P to refresh the preview. What's that?
I didn't explain when I did it before, but the syntax you have here where you've got your open quote,
oh yeah,
a slash, a parenthesis, the name of our variable, and then another parenthesis, that is allowing us to put our variable inside of a string instead of, like, if we just put row, it would put the word row, but we want the value which is our row. So that's our 0, 1, 2 in this case. And that's called escaping the string when you put that little syntax around your variable.
Yep. All right, so in each of those rows, I want to do another loop because in each row I want 3 buttons. So I actually want another for each. So this is looping over the columns. So the column in. And now we got to figure out, so here, I'm just going to do my text thing. So this is just a fun little math problem. Row is row, column is column. So now we have a little grid column. I feel like 0, 0, 0, 1. Why are there 2 instead of 3? See what I mean? Oh, because I didn't give it any stacks. These are all just part of this same V stack.
Yep.
So I'm going to put my rows in a V stack. Maybe I don't need an extra V stack, but I'm just going to do it to keep them all nicely wrapped up. And each of the rows is going to be an H stack. There we go. So now I'll just put parentheses here so it's a little easier to see what's going on. So we have our little 0s and 1s and 2s and things, and now we need to use that information, the row and column information, to figure out, what do we want? What does a calculator look like? 1, 2, 3, or is it 1, 2, 3 at the bottom?
I'd say 1, 2, 3 at the top. No.
The funny thing is, a phone has 1, 2, 3 at the top, and a calculator has 1, 2, 3 at the bottom.
What does the calculator app on the phone have?
It's this. All calculators and cash registers look like this, and all phones have 1 at the top. For various esoteric reasons involving their design predecessors and rotary dials and old-fashioned cash registers and things.
Well, we already know that our calculator is different.
Yeah. So just to keep the math simple, because this session isn't really about the math, we'll just do one at the top because that's easier. Otherwise, you got to subtract stuff from stuff and things. So let's see. So row 0. So if this is, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to take, if we add those two numbers, let's see, 1. Okay, yeah. So it's going to be something like, let me replace this. We know this starts at 0 and we want to start at 1. So whatever it is, it's going to be something plus 1 at the end. And I think it's going to be whatever column we're in times whatever row we're in, because each time we go down a row, we want to jump by that many things. And then I'm of course missing something or getting something slightly wrong.
0 times anything.
It's not times the row, it's times the number of, it's the row. I'm definitely going to get this backwards. It's row times the number of columns, because each time we want to wrap one by one column amount, plus the column to figure out how far we are over from the left. There we go. So the row we're on times the number of columns, because each time we jump down a row, we're adding the number of columns to wrap around to the next one, plus the column to figure out how far we are over from the left, plus 1, because if we didn't plus 1, the whole thing would be shifted back by 1 and we'd start at 0. And for, again, weird reasons, we start at 1. And then down at the bottom, we're going to do another button. So anyway, this, I'm going to pull this all out as a variable and say, let number is that. And then we're going to make a button view. The title is, do that little string interpolation thing again, and add digit number. And then we're just going to throw in at the end a 0 button. After, I think we can just put it outside here inside the VStack and throw in a 0 button. And then get rid of those test buttons. Keypad.
Sweet.
That's fun.
Yeah. What else can we do?
Well, if we're talking Swift UI, I mean, it's just fun to demonstrate that, like, especially if you're coming from certain other like UIKit or other tools, it's just neat to see that you can do stuff like, oh, I'm just going to take this and rotate it. What is it? Rotation effect. Boy, autocomplete is not doing us any favors.
So this is a beginner night, not a beginner Swift UI night. Right. So let's take a half step back and let's talk about for eaches. I feel like we covered it, but like pretty lightly. So a for each is a type of loop in programming, not just in Swift or Swift UI, and it does exactly what it kind of implies. So for each value, it's going to do something. And so here we're providing it the range of from 0 to 3. So for each of these 3 things, starting at 0, we're going to do something. What is that something? Well, we're going to create our number, which is that fun math, and then we're going to create a button view. There are other kinds of loops, not necessarily in Swift UI, but in Swift, such as a while loop. That's something that sort of continuously runs, going over and over and over things until it hits some precondition and ends. You might want to do that if you have something you want to constantly check the value of, and when it has changed, that's when you stop. So maybe you're waiting for a network call before you refresh your UI. I wouldn't do that. That's a bad example, but maybe you are. You could do something while you're waiting for it to happen. This for each is kind of a special example of a for each loop where it gives us the extra closure. We still get that with a for each loop. This is a special one because it creates a view as part of the output of its closure. And a closure, we talked about it at the very beginning, declaring a function like we have down on line 60. A function is, a closure and a function are very similar, where they are a selected block of code. Closures, functions can be passed around as closures. Closures can be thought of like functions where you're executing them. The kind of difference in syntax is interesting, where here we're passing in digit. That's kind of what column is here. We're passing column into this. And so our button views have a closure at the end of them. We're not passing anything in, we're just saying, hey, run this code. Instead of passing all that in, we can say action add digit. No, that's a bad example. We're going to do it up here. Action is...
Get rid of that print. I was playing with something.
Action is add digit number. And then we can actually get rid of this trailing closure and simplify our code a little bit more.
I'm not sure. We'd have to curry it to make that work. Exercise for the reader. Go look up currying. It's cool.
Yeah.
Because that doesn't return a closure.
Does not return a closure. Right. Right. There goes my... That works in other scenarios, but not in this one. It would have worked
if add digit didn't take any parameters, like if it was the clear function.
Yes.
Actually, that would be a good example. That would work. If you wanted to pull clear out into a function and then call it from the clear button. And it is a good idea to pull functions out so you're not just running the function in your button action directly, or not like doing stuff in your button action, just because it gets messy. And like if you want to then call that from somewhere else, it can be weird. You don't call it, you just pass it. So yeah, let's see if this compiles, because I was playing with this and we can get rid of it. Okay.
Oh, you can't print inside of that. That's...
No, I was trying to. You'd have to basically do a like a on a peer or something. Yeah. So we have a function here and we can just call it, but instead of calling it, we have a button view that is expecting this syntax means a closure that takes no arguments and returns no value. So it does whatever is inside it, but it doesn't take anything or return anything. And this here is a function that takes no arguments. And if you don't write a return value, it's implicitly returning no values. So it happens to be the same shape, function that takes nothing and returns nothing. And so instead of calling it, you can pass it directly and say, hey, you wanted a function that you could just call and it would do stuff. Here you go, call it whenever you want, which is a pretty powerful way to think about sort of taking little pieces of your code and handing them around to different parts of the app.
And I think that alone being a good coding practice, it's an especially good coding practice when you start talking about something like Swift UI, because this again is getting quite large. And when this got large before, we extracted out our button view into all of this if you're just joining us. And so at least when I'm writing code, like I generally start by putting everything in one place until it gets too big, and then I start moving it to other places and smaller places and smaller places. And this is a conversation we've actually had a couple of times with people in our Slack group, or now our Discord, Discord and chat if you'd like to join, where it's just like, my code's really hard to, like, I'm having this bug, and then we go and help them, their code's really hard to read. It's like, okay, well, let's start like pulling these little pieces out and let's make them smaller, more logical pieces, and then from doing that you can really start to find where bugs are when you start isolating chunks of code. and sort of, I guess, to do as we preach, let's add a function for, what do you, equals? Complete, is there a better word?
Evaluate.
Evaluate.
Flush.
I feel like evaluate's a mathy term.
If you're going to do one for plus, you want to use extract refactoring.
Sure. So what Zev is hinting at is I can highlight this and I can click on it and go to refactor and extract to method. It will go ahead and take that code out for me.
It sometimes works. Try a build first. I think it just got very confused.
Yeah, I'm going to stop the preview as well. It's already stopped.
Xcode syntax highlighting just dies sometimes also. It's really fun.
That went to extracted function, the one up here. So yeah, Xcode went ahead and made this extracted function for us after getting a little bit drunk, but we can do the same thing, right click on it, refactor, and we can rename it. Again.
Just made a goofy sound and a hand gesture for nothing. Wouldn't be the first time.
Has it gone silly again? It has.
You can do rename light, which is Command Control E, edit all in scope.
Yo. Things you learn. And then just to make this look the same as the others, we'll do action.
If you're interested in this thing of like passing functions around as values, there's some really cool stuff you can do with it. I recommend, I'll put a link. It's the Objective-C.io functional Swift book. There's some really cool examples in there, interspersed with some really dense chapters about like computing theory that you can just kind of ignore.
Yeah, the first time I read that book, I got really confused, then I got really angry, and then I got really confused again. It's a very heady one.
Yep.
Not for the faint of heart.
It's good to read with a friend. We did it as a book club.
Yeah, it's a good book club book. What else?
What else? Feel free to throw questions in the chat. Yeah, there's definitely some weird examples, and like you'll read one chapter and it gets it's like, oh, this is super practical. I can see how, like, the next time you look at your own code, you go, oh, I see where I can change this, and then you read the next chapter and it's like, this is maybe interesting in a math class, but like this is not useful for programming, and it's unfortunately hard to figure. If you're seeing this stuff for the first time, it's hard to know which is which. So definitely good to have a buddy or a Discord where there's a bunch of people who've read it and can chat about it. For
exclamation point Discord and chat. So I guess for giggles, I did have last year's beginner's night on my hard drive as well, or might have been one from earlier, like in the middle of summer. I think we did a beginner's night. Let's look at that calculator by comparison.
Nice. IB actions.
Yeah.
Lots
so
of them.
Before Swift UI, there were different ways to make UI. A popular one that Apple tried to push hard on us was called Storyboards. And so you can see I put all the UI here. This is kind of like our preview, but I can't really click and interact with things. And the way that I built this is I actually dragged and dropped things on there. which is why Apple pushed it, because it makes building UI very simplified. But then to hook up this interface file, we had to create things called IB actions that Zev got pumped about. And so we had to make one for every single one of our buttons, because we didn't have nice little for each loops that lets us iterate and do little chunks of code. Now I could have done that writing my code programmatically, and we would have had similar results, but it's still not as quite as nice as it is in SwiftUI. And I have a whole bunch of IB actions, so every time you tap on a button, I'm doing something. This version of the code, I think, highlights the language Swift a whole lot better, whereas like when you're writing SwiftUI, just because it has Swift in the name, you're not really doing Swift, you're doing SwiftUI. It's kind of like JavaScript and Java being nothing at all like. You can look at their similarities, like there's some syntax, some words make sense, but
yeah, SwiftUI introduces some things that like they are technically part of the Swift language or are going to be shortly, but they're so kind of weird and like doing their own thing that it is really like its own, like, it's Swift code because they're running the same compiler. Yeah, Freemio 07 is SwiftUI is a DSL. It's a domain specific language. So on top of all the language features of Swift, they've used those features to make it so that you can write stuff in a certain way that sort of translates back into regular Swift code, but it doesn't really look like Swift code. It's set up specifically to make it very good at writing UIs and pretty much bad at everything else.
Yeah. But what I do like about this style is the code's a lot more explicit, whereas in SwiftUI the UI is a lot more explicit. And so you kind of want to strike a balance, in my mind, of tools for the job. So like you can have an app that's built that has both UIKit and SwiftUI, and so you should really carefully choose when to use which tool, because one might not always make sense all the time, both SwiftUI and UIKit. So
especially right now,
yeah,
SwiftUI is still 2 years in. It's still very new, and there's very much impossible stuff that you just can't do with it right now.
Yeah, I think long term, eventually SwiftUI will take over everything, and everything will be great. But we're definitely in a weird in between, which we went through with Swift too. Like there was a while where every app was Objective-C and Swift because you couldn't do everything with Swift, and now you can do everything with Swift, so there's really no need for Objective-C. And we're starting to see a similar transition with UIKit and SwiftUI. So when I'm asked what should I learn, it's really hard to answer, because like if you join a team, like if you get a job and you're on a team, you're probably going to have to interact with UIKit. If you're beginning to learn on your own, SwiftUI might be a little bit easier to understand.
But even if you set out to write a pure SwiftUI app today, like I've got 2 little side projects going that are ostensibly pure SwiftUI, and they're like half either UIKit or AppKit, because like wrapping text around images, oh, you can't do that in SwiftUI. Fine control over where you scroll in a table view, can't do that in SwiftUI. Good handling of NS document on the Mac and maybe on iOS, can't do that in SwiftUI. So you have to, and the interop is pretty good to incorporate bits of both. Like they had to do that because SwiftUI was so incomplete at the start. But I think we're still very much at the stage where if you're doing anything that's basically not in Apple's sample code, you're going to be writing some wrappers around some UIKit or AppKit things for now. And, they'll get better. They got better this year. They'll get better next year.
The two notes asks what can't be done in SwiftUI. What are the main shortcomings?
Yeah, so some of those things I mentioned. A huge one actually for me was I have this little juggling math app, and you type in numbers and they need to be evaluated as like, is this number a valid juggling pattern? Which is why I was doing keypad stuff incidentally recently. And so I'm like, okay, I want a text field, and when you type in it, I want certain characters to be illegal, and really that was it. Like, that's not a big ask, right? Like, that everybody can do that in every web and iOS and whatever thing. But to do what I wanted to do, I had to go back and wrap UI text field and NS text field, because it was not possible with the formatter integration with Swift UI, as far as I can tell. It's just like editing while formatting, going back to the middle of the string and typing a character, like, stuff's just either not supported at all or theoretically supported but broken. And so you got to go back and write some wrappers. There's something else I'm going to write a wrapper for, because the string stuff, like the way text works, is pretty nice if you're doing basic UI strings and like good for accessibility and stuff. But like, you can't do a clickable link inside a block of text in Swift UI. That's not a thing. You have to go back and write that as a UI text field or something, or UI text view or something. And handling, like, Swift UI doesn't support attributed strings as far as I know. So if you have some library or set of functions that builds up a styled string where like different parts of the string are different colors or different fonts or whatever, you basically have to rewrite that for Swift UI, and it's not as powerful. It can't do nearly as many things. Like, back in UIKit land, you can do all this advanced stuff with fine-tuning the kerning and the paragraphs and insets and text layout, and like, perhaps understandably, that's not supported in Swift UI, and I don't know how much is going to be, because Swift UI is very opinionated, as like, this is a library for building app UIs. So, is the reading part of a book reading app a UI? Well, not really. It's kind of its own custom content thing. So they don't really expect you to do that part in Swift UI. But there's some annoying places where those overlap. Like, I have a footer in a settings view that's like made by me, and my name is highlighted blue, and you can tap it, and you can't do that in Swift UI right now.
But you can. Apple does provide a way to wrap UIKit things into a Swift UI view. So you could take the UIKit, I'm assuming using a text view, and you can wrap that in. I can't remember what it's called, but whatever it is in Swift UI.
Yeah, if you want to look it up, there's a good article on NS Hipster about it. It's UI view representable.
Yeah,
is the way to take non-Swift UI things and render them in Swift UI, and UI hosting controller and UI hosting view controller, something along those lines, to go the other way, to take Swift UI stuff and run it in a UIKit app. This is a specific article about using previews with non-Swift UI apps, which is actually pretty cool. I've used that on an app, and it was pretty neat. Like, we couldn't use Swift UI for reasons, but we could still use the previews, which was neat. But maybe there's not an NS Hipster on UI view representable specifically, but it's used in this.
Yeah. And what I was trying to do while you were talking about some of the shortcomings was, I don't know if it's still a thing, but I thought you couldn't even do a text field in Swift UI.
It's a thing. There's a thing called text view, I think, or text. What is it? If you start with text, you'll get there.
I wasn't getting there because Xcode.
Try text field. I forget.
Maybe if I do it on a view that has smaller things, it will come back to us.
Well, Xcode's documentation search, I feel like it used to show everything, and now it just gives you like the top 8 results, and then you can't. Text field says the 2 notes, thank you, in the chat. Yeah, and like, when you can do it in Swift UI, it's usually better and nicer than UIKit. Like, as in the 2 notes example there in the chat. You make your text field, you give it the little placeholder. That $sign means you're giving it a binding to some text, which we didn't really talk about tonight, but it basically says, I'm giving you this text input, and whatever the user types, it's instantly in that variable. And if that variable ever changes, the value on screen is changed, and you just never have to worry about keeping them in sync. Like that's so many people have written so much fiddly code to keep that stuff in sync, and now you just don't have to worry about it. So the Swift UI future is rosy, but they have to rewrite. What are we? Swift UI came out in 2019, and UIKit came out in 2008. So we're like 11 years in of a very mature UI framework that was built on top of AppKit, which was a 20-ish year mature UI framework. So like, I'm not faulting them for not having everything ready to go on day one, but it's a bit of a rocky start, if you want to jump into it.
Yeah.
But that's always the way with Apple.
Cool. So I feel like we covered more than I thought that we would in the night. So I don't really know what else to do other than to thank everyone for watching. Thank you, Zev, for popping in. Appreciate the backup in chat and then again in person ish.
Pleasure.
I hope this inspires a bunch of people to either get into Swift programming or app development in 2021, or if you're like myself and you're new to Swift UI, maybe 2021 is the year for Swift UI. I know I'm going to try and be better about doing Swift UI in our meetups, depending on how complex the topics are. So keep coming out here the third Thursday of every month. We're going to be live streaming our meetup until it is safe to meet in person again. So I would expect us here all 2021. So good luck learning Swift. Join our Discord if you have questions. We're happy to help, and we'll see you in the next one.